students. By this video, let us study about the physical properties of ammonia. So, by the last videos we understood how ammonia is prepared. By this video, we see the physical properties. Yes. So, ammonia we know it is a gas NH3. Its formula is NH3. So, this ammonia gas is colorless gas and it is having a pungent smell, pungent odor gas. So this gas smell is not tolerable to us. Once we inhale this gas, our eyes turns watery. We will not be able to tolerate it. Fine. So this ammonia gas smell, understand it by going to the chemistry laboratory. There if you take ammonium carbonate, open the bottle of the ammonium carbonate, you get the smell of a gas, so that gas is nothing but your ammonia gas. Okay. Now looking at the vapor density of this ammonia, vapor density of ammonia is 8.5. Yes, when we compare the ammonia vapor density with that of air, it is less. So for air, the vapor density is 14.4, whereas for ammonia it is just 8.5. So for that reason, ammonia is lighter than air. Understanding? Fine. Now let us look at the third point, that is ammonia is basic in nature. So that is understood by this reaction. Ammonia, when it reacts with water, it forms ammonium hydroxide. So this ammonium hydroxide NH4OH, it is a base. Yes. So because ammonium hydroxide is a base, when we do the litmus test, the red litmus paper turns to blue. Yes, so that indicates that ammonium hydroxide is a base. So base is obtained by ammonia reacting with water. So this ammonia is basic in nature. So that is indicated by color change of the red litmus paper to blue. The next point is it is highly soluble in water. Yes, so at 20 degrees Celsius and 760 atmospheric pressure, ammonia is highly solubilized in water. Yes, so here it is said that 702 volume of ammonia can be solubilized in 1 volume of water. So that means in water it is highly solubilized. Okay, and it can be also easily liquefied at 9 atmospheric pressure. So, 9 atmospheric pressure, ammonia gas can be liquefied. Okay, then this ammonia liquid, after liquefying this ammonia gas, the ammonia liquid, so that boiling point is minus 38.5 degrees Celsius and the freezing point minus 77 degrees Celsius. Okay, then this liquid ammonia, it resembles to that of the physical properties of water. Yes, so we know that water is having a strong hydrogen bonding. Likewise, here also there is a strong hydrogen bonding existing in the case of ammonia too. Fine. Then water undergo auto-ionization. So likewise, ammonia also undergoes auto-ionization like that of water. Fine. So auto-ionization means self-ionization. Yes, water, if it undergo ionization, it gets split into H3O plus ion and OH minus ion. So that is the ionization of water. Likewise, ammonium also, they also get ionized. At low temperature, ammonia form 2 soluble hydrates. At low temperature, ammonia it forms 2 hydrates. Soluble hydrates. So what are they? They are NH3H2O and 2NH3H2O. So these are the hydrates of ammonia. Okay. So at the low time, when the temperature is very low, in that case ammonia will combine with the water and they form hydrates. Okay. And it is generally forming hydrates. Okay. So that is with 1 water molecule and 2 ammonia with 1 water molecule. So these are the 2 hydrates of ammonia. In aqueous solution, ammonia is hydrated as NH3H2O. That means when ammonia is mixed with water, the water molecules get combine with ammonia NH3 and it becomes hydrated ammonia. Got it? So one water molecule is getting attached to ammonia through a hydrogen bonding. Okay. Now let us look into dielectric constant of ammonia. So dielectric constant of ammonia is very high. That is 25% of ammonia solution, the dielectric constant is 31.6. So for 25% of ammonia solution, it is 31.6 the dielectric constant. Then for 100% solution, dielectric constant. Fine. So it will be much greater, right? 31.6 you multiply by 4. Yes. So that means ammonia is having very high dielectric constant. So like ammonia, water is also having high dielectric constant. So for that reason, we tell that water is a good polar solvent. It is a universal polar solvent. That means it can solubilize anything other than the organic compounds, right? So that's why we tell it as water is an universal solvent and anything can get dissolved in water. Fine. So likewise, the dielectric constant for water is also very high. So now we'll be asking me the question, what is this dielectric constant? So dielectric constant, it is just the measure of solvent polarity. So when the polarity is higher, that means greater will be the ability to stabilize the charge. Okay. So when polarity is higher for both the ammonia and water, then these solvents will be having higher ability to stabilize the charges also. Okay. So that means charge separation. So when ammonia is mixed with water, ammonia get ionized into NH4 plus ion and OH minus ion. That means the charge is getting separated. So once the charge is getting separated here, that means ammonia is completely getting solubilized in water. Okay. So for that reason, because of the higher dielectric constant in ammonia, ammonia is acting as a good ionizing solvent like water. So when ammonia combined with water or it is undergoing ionization. Yes. So likewise water also undergo ionization to form H3O plus ion and OH minus ion. So likewise ammonia also when it combined with water, it forms NH4 plus ion and OH minus ion. So because its dielectric constant is very high, ammonia is a good ionizing solvent. So it can ionize all the solvents like water. Ammonia undergo auto-ionization like that of water. So this point we have already seen before. Now let us study how this ammonia and water, they undergo self-ionization. Yes, and they undergo splitting and form ions. So that ionization or auto-ionization that we are going to study. So first let us take the example of water. Okay. So two water molecules, H2O, H2O. Okay. So two water molecules undergo ion to form OH minus and H3O plus ion. Okay. So two water molecules combine together and they undergo ionization to form OH minus ion and H3O plus ion. Right? So how this OH minus and H3O plus ion is formed, that is your ionization, splitting. So how that splitting takes place, we will see here. Okay? So first this water, we will just write it like HOH. So this water, when it is split, it forms H plus ion and OH minus ion. Right? H plus ion and OH minus ion. Okay. Now, this water, this H2O, it donates this proton. It donates this protons. So, gives H plus ion, donate this proton. Okay. So, when this proton, because this H2O, this water donates a proton, so this is called as acid. So, this water is considered as an acid. Okay. Now, this H plus ion, that is the proton, this is accepted by this water, H2O. Okay. So, because this H2O is accepting this H plus ion, this becomes a base. Got it? So, if water, OH minus ion. Okay, and this H plus ion is accepted by this H2O and it becomes H3O plus ion. Understanding? Now this H3O plus ion, so it is also having H plus ion, so they can also donate H plus ion. They also can donate the proton. So because it is acting as it can donate a proton, so this can be considered as an acid. This can be considered as an acid because this acid is produced from this base. This acid is produced from this base, so this acid is called as conjugate acid. Conjugate acid. Got it? And this OH minus, it is acting as a base. Yes. So again, it can accept H plus proton. Yes, it can accept a proton. So when it accepts a proton, it can get changed into water molecule. Okay. So because it has the capacity to accept a proton, so this is called as a base. Okay. Now this base is formed from this acid, right? This base is formed from this acid because this water it donates a proton, and when it donates a proton, it becomes OH minus ion. Okay, so this OH minus ion is a base here. Okay, so because this base is formed from this acid, yes, this base is called as the conjugate base. Understanding? Clear? Yes. So water has a capacity to act as both acid and base. Yes, water accept a proton and become an acid, and water accept a proton and become a base, and water donate a proton and become an acid. So water is having an amphoteric nature. Amphoteric nature. Why water is having this amphoteric nature? Because water can accept a proton and it can become a base, can act as a base, and at the same time water can donate a proton and it can become an acid. So for that reason water is considered as having another property. It is considered as amphoteric in nature. Understanding? Now the same thing, we'll just look into the ammonia here. Okay, so two ammonia molecules combine together. When they combine together, they undergo ionization. So this is a reversible reaction. They undergo ionization. Their ionization they forms NH4 plus and NH2 minus. So we'll see how the ionization takes place. Fine. Now this ammonia NH3, I will just split and write here. Yes, NH2 minus and H plus. So ammonia, I just write it like this. I just split and write ammonia as NH2 minus and H plus. Okay. Now this ammonia donate a proton. Because this ammonia is donating a proton, this ammonia can act as an acid. Okay. Now, so when this ammonia donates a proton, what happens to some NH2? What happens to NH3? NH3 will become NH2. Understanding? Yes. So this NH2, I just write it over here. So ammonia, it donates a proton. So this proton, because it is donating a proton, it becomes NH2. Okay. So that I have written here. And this proton, it is accepted by this ammonia, NH3. Okay. So for that reason, what happens? This becomes NH4. So that I have written here, NH4 plus. Got it? So this is the way how ionization takes place. So now, because this ammonia is accepting a proton, this ammonia is acting as a base. Why this ammonia is acting as a base? Because it is accepting a proton from this ammonia. Okay, and so this ammonia is acting as a base and this ammonia is acting as an acid. So here too ammonia exhibits the amphoteric character, amphoteric in nature. Why? Because ammonia acted as both acid and base. Understanding? Now this NH2 minus, yes, so this can accept again a proton. This can accept a proton and it can become ammonia. Okay, so because it accepts a proton, H plus ion. Yes, so NH2 minus, so this becomes a base. This base is formed from this acid. This base is formed from this acid, right? So for that reason, we call ionization of water. So both water and ammonia, they are acting as amphoteric. They are having the amphoteric nature. They can act both as an acid and base. Fine. Now let us look into the stability, that is equilibrium constant. Equilibrium constant shall be right for you. Okay. So for ammonia, the equilibrium constant is K. Now let us see the equilibrium constant value for this autoionization of ammonia. So here the equilibrium constant at minus 50 degrees Celsius, it is, to write the equilibrium constant, we always write the product in the concentration. Product concentration we write. So NH4 plus and NH2 minus is the product. So that we write in the square bracket, that indicates nothing but the concentration of the products. So NH concentration of NH4 plus 1 into concentration of NH2 minus. So the equilibrium constant is, for this autoionization reaction of ammonia, is approximately equal to 10 to the power minus 30. Fine. Now likewise, at 23 degrees Celsius, the equilibrium constant or the ionization constant for the autoionization of water. So in this case, it is equal to 10 to the power minus 40. Okay. So this is a calculated value. Fine. So the calculated value is based on the concentration of the products here. So HCl plus iron and OH minus iron. Fine. So this is the equilibrium or the ionization constant for autoionization of water, that is 10 to the minus 40 at 23 degrees Celsius, and here at minus 50 degrees Celsius, the equilibrium constant for autoionization of ammonia is 10 to the power minus 30. Yes, so that's it about the autoionization of ammonia. Fine. So hope you understood the reactions